Hello, I'm Verena Beckham from CodePlay Software, and me and my colleague Ken Wenger from Core AVI would like to invite you to join the SYCL SC Exploratory Forum. We think now is the right time to start developing a new safety standard within Khronos. Khronos' Safety Critical Advisory Forum has expressed a general need for standards that adhere to safety critical guidelines. At a recent ML Summit, also organized by Khronos, participants have expressed a need for high-level abstractions for the use in safety-critical applications. And AUTOSAR, which is a partnership of automotive companies, have asked to set up a liaison with Khronos, which shows that automotive is looking for standardized APIs. Automotive is just one example. Safety-critical industries include all industries where safety is paramount, including, for example, avionics, nuclear, and rail. In these industries, all software has to adhere to safety standards, such as ISO 26262 for automotive or DO 178C for avionics, and it has to follow state-of-the-art guidance from groups such as AUTOSAR and MISRA. This means that the APIs they use also have to follow these guidelines and not hinder the certification to the standards. What's more, hardware and software complexity is growing in these safety-critical systems. The software used to be written in simple C, but C++ is being adopted more and more. The hardware used to be restricted to single core, whereas the consensus now seems to be that for advanced features, multi-core and heterogeneous architectures are going to be inevitable. However, there is currently no high-level API to program these advanced algorithms on the next generation hardware in the safety critical space. This gap is where we think SYCL SC would fit. We expect artificial intelligence and vision applications to be the main use cases for such a high-level API. This is how SYCL SC would fit into the AI ecosystem. Applications consist of a combination of neural network models, decision-making, and various glue codes such as data processing. The neural net models can be generated using a variety of platforms such as PyTorch or TensorFlow. The model can be converted into the neural network exchange format NNEF defined by Khronos before being passed into the API for inferencing. The application can make use of OpenVX's safety critical profile to perform the vision and AI tasks, and the more general compute and the proprietary algorithms are accelerated by SYCL SC. On the lower level, it's typically OpenCL that is generated from the higher level APIs, or it could be Vulkan SC, which has recently been announced. Vulkan SC is another safety-critical API, which is based on Vulkan, and by implementing SYCL SC on top of Vulkan SC, the whole runtime stack up to application level could be safety certified. Vulkan SC is a low-level API providing an execution layer for graphics as well as compute. OpenVX has a deployment feature set which can be used to implement safety-critical vision and neural net algorithms. However, there is no high-level compute API for safety-critical applications. SYCL SC would bridge the gap between low-level APIs and high-level programming environments such as C++. SYCL is already a well-established standard, which is used for high-performance computing, artificial intelligence, and machine learning algorithms. SYCL SC will allow these kinds of algorithms to be developed in a safety-critical environment as well. SYCL SC would use the same definition and scope of safety critical as Vulkan SC to remain compatible. The three aims are deterministic execution, which means the execution times and results should always be the same on every run given the same input. Robustness, which includes solid error handling, removing ambiguity and documenting undefined behavior. And simplification, which means the effort that is required for the implementation of a runtime to be certified according to safety standards is reduced. What that means for SYCL SC is that we will be trying to make the API conform to the MISRA C++ guidelines as much as possible, while at the same time trying to remain as close to the standard SYCL as possible. There are updated guidelines currently in development, which we hope to target when they are released. Any non-conformities will be documented, so the reasoning can be integrated into a user's MISRA deviation rationale. To allow SYCL runtimes to be more easily safety certified, we will ensure that SYCL SC will work on top of Vulkan SC, which is currently the only low-level compute API that is ready for safety critical. We will likely remove some SYCL features, or at least make them optional, which could include, for example, the online compilation path and other features that are not essential and unlikely to be used in a safety critical context. By reducing the size of the runtime, it will be easier to certify. And we will likely also want to add features that are useful in a safety critical context. For example, extensions that allow for greater control over the timing of the application. We have created this exploratory forum to gather requirements from the industry, so we can develop a standard that addresses the needs of those who will use it. Any company is welcome to join, whether they are members of Khronos or not, and you don't have to join Khronos to take part. There's no cost in taking part, and there are no IP licensing obligations. There is, however, an NDA to sign before joining to cover the discussions we will be having within the group. We are planning to meet on a weekly basis, virtually, using Zoom. And at this point, we are not looking to go into detailed design discussions, but the final aim is to produce a scope of work, which will capture use cases, requirements, and objectives. This scope of work can then become the basis of the creation of a full working group within Khronos, who will develop the details of the API. The exploratory forum will proceed in roughly 3 stages. At first, we would encourage members to briefly present what they can about their use cases, requirements, pain points, and experience. Then we will be having discussions in the group on whether and how SYCL SC could address some of these requirements. And following on from that, we will try to get consensus on design goals and features of this new standard, working towards a release of a scope of work document. There's no time limit on discussion, so we will continue discussing for as long as we need to, but we expect each stage to take perhaps a few months. So please join. We invite companies, universities, consortia, industry experts, open source developers, and we especially want to hear from end users in safety critical industries to understand exactly what they need from a high-level heterogeneous compute standard. This is a great way to influence the creation of a new standard, to ensure that it provides the features that you require. If you want to just join once and present your views, that is also fine. Our first meeting will be on April 4th, and you can register your interest on the website shown at the bottom here. We hope to hear from you.